So far with higher order functions, we've focused on using them rather than defining them ourselves. And to that end, we've worked with things like map and filter, just to show that we can abstract away common patterns that we see when using Haskell. Today, we're going to do a similar thing, and today we're going to generalize the zip function by implementing our own version of zipWidth. Now, the zip function is something that takes two lists and stitches them together element-wise as it goes along. You can see up here it takes the list 1 to 3, 3 to 5, puts 1 with 3, 2 with 4, and then 3 with 5. So it just takes out the first element of each list, puts them together, and then puts them in a new list. It's a fairly simple function, however there is a higher order version called zipWidth. Now zipWidth has this type signature here, you see it here as well, which takes a function from A to B to C, a list of A's, a list of B's, and returns an element of C. So you can probably infer what the application is going to be. It's going to convert the lists of A's and B's by using the function that's applied to give a final list of potentially different types. So that's what we're going to do here together today. It's going to be a bit more complicated than map and filter. I would do examples on them, but you've already seen quite a lot of functions that look like them, as we've done quite a lot of work on lists. But zipWidth is a little bit more complicated, so let's see how we would do this. Okay, first we'll get rid of this. We don't want our undefined in there. That's just to make sure it doesn't have any type errors when we load in the file. So now I need to give a function, so we'll give that something called f. That's going to be our function from A to B to C. Then I need a list of A's and a list of B's. But I need to consider my base cases. So what happens when zip is given a list that's longer than the other is it will always terminate on the shortest list. So for example, if you give it a list of 1 to 5 and a list of 1 to 100, it will only do 1 to 5. Actually, we can see this if we put zip and we do 1 to 5, then 1 to 100. We'll only get the first 5 elements from the list. So zip will always terminate based on the shortest list because it doesn't have anything to pair the other list with if it's longer. So what we need to say in the first couple of instances is what happens when either list is empty. Now, you should be able to infer that because there's two lists, we need to pattern match over both of those. We can't just do it on one. We need to say what happens when either of them are empty. So what I'm going to say is, for the first one, when that's empty, that should be equal to the empty list. And the reason I say this is because we're building up a list in the end. So when we're building up a list, generally the base case is always going to be the empty list. And similarly, for an f, for some unknown value in the first one, the second one's empty, we also return the empty list. So that's me just pattern matching over the two cases I can have when either list is empty before the other. I mean, they both could be empty in both of these cases. That's why I've used wildcards here rather than instantiating some value. But it's just to check if either list is empty. Then we just finish. So now we actually have to do the function application. So I'm going to say I have a list of A's, A colon A's, and a list of B's, that'll be B colon B's. So now I need to focus on how I'm actually going to build the list up. You might think this is going to be difficult. It's really quite straightforward. Again, with higher order functions, what I really want you to think of them as are ways to abstract away common processes. So with map, it was transforming lists. With filter, it was filtering lists. We'll see other higher order functions later on in the course. But my zipWidth is just combining lists. That's all it's abstracting away. So what should we do? Well, we have a function that converts things to C. I know that anything that's involved in the output should be of type C, so I'm going to have to convert something to type C. And I have a list of A's and B's, so I better apply F to A and B. This is the only thing that I can do in this situation, and it's the only thing that would give me the right type. And then I can say my zipWidth, and this could be F, A's, and B's. And that's my zipWidth. You see, all we do is we apply F to the first elements of the list and then concatenate them onto the rest of the list. So again, this is a common pattern. You could indeed build this up with other functions if you wanted to, but this is a very simple way to define this. Now, if we come into here and we reload this, what we can do is we can build up the old zip function. Now, it's going to be a little bit more difficult, but if we look at this list up here, so let's worry about giving it a function in a second. I just give it these arguments. And then we can see how we can define the old zip from the new zip. So I'm going to have to give it a function of some type. Now to define this, I'm going to give it lambda. You could give it something else, but I'm going to give it a lambda. So it's going to be something that takes an x and a y and goes on to do something with it. Now what is it going to do? Well, if we look up here, it should just be putting them into a tuple. So I can just say, put x and y into a tuple, and that's me. So this is just a simple lambda to give us the same behavior as zip. So you can hit enter and you can see my zip width is just a generalization of the original zip, and that's why we would want it. We would want something that's more general, because by being more general it has more value, more use for us. Now of course we could do anything we want with this. We could do, I would just drop the x's and then we have something that just takes the first list, or we could have something that does x mod y, and that should give us all zeros. So we can do anything we want with this function as long as we're converting list to list. We could even recombine these into shorter lists if we wanted to, so we could build lists of lists. So that would just be x cons y. And as long as we give it the shape of the output, then we can do whatever we want. So this is just to give you an idea of how you would go about defining a higher order function. They are relatively straightforward. The only thing you need to worry about is this f here, and you need to make sure you apply it on the right hand side of your definition. And that's it. So there's not much to it, but of course if you have any questions about this, please do get in touch. Thanks.